Welcome back to our next video on algebra. So today we are going to discuss few very basic and important theorems that we use in solving polynomials and equations in algebra. Now let's for example take a polynomial p of x which is equal to x square plus 3x plus 2. Let us for example take one more polynomial, say g of x, which is x plus 1, and I'll tell you why I have taken this polynomial x plus 1. And now let us divide p of x by g of x. P of x divided by g of x. Taking the long division method, this is p of x divided by g of x. So it is x times, it gives us x square plus x. This x square will cancel with x square, we'll get 2x plus 2, and when we multiply this divisor by 2, we get 2x plus 2, and the remainder which we get is 0. So which means that the factors of this p of x, which is equal to x square plus 3x plus 2, can also be written as multiples of x plus 1 and x plus 2, or for that matter x plus 1 and x plus 2 are the factors of the given polynomials. So these are the two factors of a given polynomial. Now let's take one more example where say p of x is equal to x square plus 6x, sorry, it's x cube plus 6x square plus 11x plus 6. Now if we are going to take a long division method route, okay, or if in case we are going to find the factors of this, we will find that the factors of this polynomial is x plus 1, x plus 2, and x plus 3. Now if you do a little observation, then you will find that when the degree of polynomial was 2, we got exactly 2 factors or 2 zeros, and when the degree of polynomial was 3, we got exactly 3 factors. Now this can be generalized as follows. For a polynomial of degree n, we will have exactly n number of, you can say, factors, you can say roots, you can say zeros. And for the students who do not know the meanings of the roots and zeros, we will discuss in forthcoming videos. Okay. Now, while we have taken 2 examples to come to this conclusion, but if in case you look, it looks pretty logical also. Say there is a polynomial f of x of degree n. right? So it may be a x raised to power n plus b x raised to power n minus 1, so on and so forth, until this, say, t, okay, t into x raised to power 0. So this is the general polynomial of degree n. We can also write this entire polynomial as multiples of, say, x minus a1, x minus a2 into x minus a3, so on and so forth, into x minus an plus some remainder r. Exponent of x here is 0. Now, if we multiply, if we open the bracket and multiply all these terms, we'll find that the degree of this entire polynomial is going to be x raised to power n. Now, if in case we had one factor less, assuming that this was not the factor, okay, then x would have got multiplied by itself n minus 1 time, and the maximum degree which we would have got is n minus 1. And if in case there was one more factor, say x minus a n plus 1, okay, then the degree of this polynomial is going to be, would have been x raised to power n plus 1, which is not case of our example which I have taken, where the degree of polynomial is n. So it looks pretty clear also from this that the if the degree of the polynomial is n, the number of roots which we are going to get is going to be n. We also call this theorem as fundamental theorem of algebra. So now we'll discuss a couple of more very important theorems of algebra, and first one is remainder theorem. Now what it states is that if p of x is a polynomial of degree greater than 1 or equal to 1, and p of x is divided by some polynomial x minus a, then remainder is p of a. Sounds confusing? Okay, so we'll explain it now. Now this p of x is a given polynomial, and this, what we are dividing this p of x is by x minus a, and what we are going to get is going to be some quotient polynomial which is q of x, and we'll get some remainder r, right? Now why I have written this is, for example, you take a number, say 17, and divide 17 by 3. Now this 17 is nothing but our given polynomial, and this 3 is nothing but this x minus a. So when we divide 17 by 3, so we get 3 5s are 15, and we get 2. So we can write 17 as 3 times 5 plus 2. 3 times 5 plus 2. So this x minus a becomes the divisor, which is 3 here in our case, and this q of x is nothing but the quotient, which in our example is 5, and this remainder is 2. So with this example, it's very clear that p of x can be written as product of x minus a, which is divisor, and q of x, which is a quotient polynomial, and some remainder r. Now here, if we substitute x by 3, it means we are going to find p of, sorry, not 3, a. We are going to find p of a. Then p of a is equal to, we will substitute x by a, so this becomes a minus a into q of a plus r. Now this a minus a is 0. So this 0 when multiplied by q of x will make this entire thing as 0, and we'll be left with r, and which is equal to p of a, right? So, and this is what the theorem has stated, that the remainder is going to be p of a. Now you will understand it more when we are going to take one example. So let us say take an example where p of x is equal to x to the power 3 minus 12 x to the power 2 minus 42, and we divide this by x minus 3. So when we divide this whole of this polynomial by x minus 3, what we get is x cubed minus 12x squared minus 42 whole goes by x minus 3. So we divide, we get, let's create some space here. We do it here. Okay, x cubed minus 12x squared minus 42. This whole things get divided by x minus 3. So it's x into x squared gives us x cubed minus 3x squared. Okay, so this x cubed gets cancelled with x cubed, and we get is 9x squared minus and minus 42. Minus of 9x squared minus 42. Now what we do is that we multiply this x minus 3 by minus 9x, which gives us minus 9x squared minus, and minus becomes plus 27x. This gets cancelled, so we get minus 27x minus 42. Now we multiplied this x minus 3 by minus 27, so you get minus 27x plus 27 times 3, get 81. Let's change the color. I will take this pink. Yeah. So this becomes plus, this becomes minus, this gets cancelled. So we get what? We get 3, 1, 2. We get minus of 123. Hence now we can say that this x minus 3 into x squared minus 9x minus 27 minus of 123 is nothing but our polynomial, which was x cubed minus 12x squared minus 42. So x cubed minus 12x squared minus 42 is equal to x minus 3 x squared minus 9x minus 27 minus 123. Now this is nothing but p of x. This is x minus a. This is our quotient polynomial, which is q of x, and this is our remainder r. Now what the theorem said was that if a polynomial p of x is divided by x minus a, then the remainder would be p of a. So let's find what is a p of a here, and a here is 3. So let's find p of 3. P of 3, which means 3 cube minus 12 times 3 square minus 42, and which is 27 minus 108 minus 42, and which gives us minus 123. And this is same what we got here, minus 123, and that proves our remainder theorem along with the example. So next video we are going to do another very important theorem of algebra, which is the factor theorem. Till then, have a great day.